In a tragic event, an explosion in the mine has resulted in the death of 9 miners, and for the investigator, a horrifying crime scene. However, the investigator was still able to establish the identities of the deceased thanks to the science of forensic anthropology. But what is forensic anthropology and how does it help us? It is a subfield of physical anthropology that involves applying skeletal analysis and techniques to solve criminal cases. This is achieved by building a biological profile that is able to tell us the age, sex, stature, or even the ethnicity of the deceased. Today, we will focus on using the techniques to identify the ethnicity of the deceased using a new technique of forensic anthropology. There are currently 3 main research gaps using conventional form of investigation. Caliper or ruler is traditionally used to estimate size of bones by measuring distance and ratio. This is time consuming, has poor reliability, high standard of error, as well as limitation on shape visualization. Other bone structure databases such as skull and long bones are readily available. However, this is not true for cervical vertebrae. In addition, bones that are commonly used for identification are often damaged in recovered skeletal remains and may not be suitable for ancestry estimation. Furthermore, the available databases are not specific to the Malaysian population and cannot be used in generating biological profile. This is especially true for the cervical bone. So, in summary, the lack of bony databases, non-specificity of the existing database, as well as the inaccuracy in conventional measurement techniques make it difficult for us to build an accurate biological profile for Malaysian. That is where we come in, a group of researchers from various universities such as UITM, USM, and Masa University, led by Dr. Choy Ker Woon, decided to develop a novel technique to quantify the fourth cervical shape variation within different ethnic groups in Malaysia. That technique is called 3-dimensional geometric morphometry. Today, our technique has been successfully published in multiple journals. Intellectual property has also been filed in 2020. We have also gone on and won multiple awards in different competitions and conventions. So let's talk about 3D geometric morphometry and how it works. How do we turn a cervical imaging like this into a biological profile that allows us to estimate ethnicity? To do this, let me take you to my workplace, University Malaya Medical Center. You see, every day there will be patients coming to the hospital for a CT scan for all sorts of medical reasons. Using the existing images that we currently have, me, the hardworking radiologist, will produce a 3D reconstruction of the cervical bone using volume rendering technique. Once the 3D model is generated, we then apply a total of 28 landmarks on the anatomical structure of the cervical bones. We did this to a total of 386 cervical CT. Phew! Now, that's a lot of hard work. Now for the result, proscrute MANOVA showed significant differences in the shape and centroid size of the C4 vertebra between races. CVA also showed significant differences for mahalonobis and proscrute distance among races. Besides that, a cross-validation value of 66.5% was demonstrated by DFA. What this means is that we now have a high chance of estimating a person's ethnicity just by using cervical bone data. In practice, we can take an unidentified deceased cervical bone, scan them with CT to obtain a 3D model of the bones. Then, we perform 3D geometric techniques by applying 28 landmarks and analyze it with morphology and compare it with the existing database to produce a unique biological profile, which then allow us to estimate the ethnicity of the deceased. We hope that 3D geometric morphometry will be an invaluable tool for ethnic estimation in future forensic investigation. Thanks for listening.